I'll make a video of this one too. So this is the question you guys are asking about. It literally says solve, so that really means I'm trying to find all the solutions, not just some of them. I should probably write down all. So what does that mean I'm really looking for? Because that's important. We need to understand what we're looking for. When it says solve or find all the solutions, what are we trying to find? The values of x? That would make this true. We're trying to find the values of x that make this true. Okay? All right, so when I look at it, let's do the structure trick. Structure trick's always great. This kind of looks scary, right? But if you just kind of look at it this way, doesn't it look exactly like something like that? See, I just covered that up with a big yellow or orange blob, just because I can deal with that level of complexity later. So if I were to say solve this for A, like solve that equation, well, I mean, your first step, add 2 to both sides, right? We're trying to isolate the variable. And that would give me the root of 3 times A equals 2. And then again, I'm trying to isolate the variable, so I divide by root of 3. And I wouldn't worry about the fact that you can't have roots in the denominator, because that's just a prettifying rule. I'm going to use that one. Beautifying. I like prettifying, though. It's better. So then you end up with A equals 2 over the root of 3. So similar thing over on our actual problem, on our trig problem. If you look at the structure, it's the exact same. So I don't even have to go back and repeat any of this. I could literally write down cosecant of x equals 2 over root 3. Or, maybe I didn't even need a substitute. I could have done the same thing over here. I could have just added 2 to both sides, and then I could have had my root 3 times cosecant of x equals 2. Then I could have divided both sides by root of 3. I don't substitute at this point for things like this. I do maybe sometimes mentally on harder problems, but I don't on problems like this. But if that helps you, then so be it. Now, we're trying to find the values of x. How many people like where we've gotten to? This right here. How many people like that? It looks nice and comfy to you. How many people hate that? Why? Because there's a root at the bottom? I don't like cosecant personally, right? Like, I have my automatics memorized. I don't need the table. But I'm not a huge fan of cosecant. I kind of think about the reciprocal functions. So for me, I would go ahead and I would change this into sine of x, which is the reciprocal. And I would just say it's root of 3 over 2. And that one's more comfy for me. So the question becomes, what angles make sine root of 3 over 2? What values of x, when plugged into the sine function, would give us a value of root of 3 over 2? And if we think back, I always like to make my little picture. The pictures help me a ton. Maybe you're better than me and you don't need those pictures. But I actually make them in my head a lot still. I make them. So I know that sine is going to be root of 3 over 2 at 60 degrees, which is pi over 3 radians. And radians are going to be important, especially if we go into calculus. But also, most applied problems, if you're ever doing an application, you're working with radians, not degrees. Because otherwise, the units kind of get ugly inside of that question itself. And so most of the time, it will be in radians. But I also know, right, that sine is positive. Because sine is the y value, I also know that sine is positive and the same size when I'm back here, at 2 pi over 3. And I know that because those triangles, if I made the triangles at those locations, they would be the same triangle, just reflected. But our y values are the same, so our opposite sides. So what that means for me is that x could be pi over 3, or x could be 2 pi over 3. What questions might you have so far? But they did say basically when they say solve and they didn't give us an interval, they really are stating they want all solutions. And I don't have all solutions yet. Why not? Turn the top. Okay, there was this little voice that spoke to me, and it said, because there's coterminal angles, so you can go all the way around and come back to it. So you have to remember that you can add 2 pi n. We just have to remember what n is important. What is n? N is an integer. Why is it super important that n is an integer? Why do we even have to say that?
Because it includes all positive and negative whole numbers.
All positive and negative whole numbers. Why can't we just say n can be any number?
So you have decimals then.
Because then we'd have decimals. And we're trying to do full rotations, right? Full units of 2 pi or full intervals of 2 pi. So n is an integer, which I'm often going to write in this way. I'm going to say n is an element of, I'm going to say it that way. And that little symbol means that n is an element of the integers. So actually, I'm on a video, so I can do this. So, n is n, right? This symbol right here means integer. And then the symbol in between, it's read is an element of. It's basically saying is any one of the, So it's like when it says is n, any one of the. So n is an element of the integers. And there we have all solutions. There's no other solutions that we missed. That's it. What questions might you have? Hypothetically, what if I wanted a list of solutions? How could I generate a list of the different angles that would work? Because I have equations right there. But I want to make sure, what if I just wanted, 10 angles? 10 angles that would work. How could I go about getting a list of 10 angles or 10 values of x that would make this true? Turn and talk. So Hayden said we could just keep adding 2 pi, and we can see those down in the bottom left-hand corner. But I literally see it as come over here to the right-hand side. I can plug any number in for n I want. So I could plug in 0. There's pi over 3 plus 2 pi 0 times. Really? It's pi over 3, right? I can plug in 1. There it is. I can plug in 2. I can plug in 3. I can plug in -5. I can do whatever I wanted, right? I can plug in any integer I want for n. So I can make a list just using the equation that we already have. That's not that bad.